Alright, so we're going to be talking a little bit about a neural gas example, but before we do that, I just wanted to show you briefly how I'm clearing out some space in my Octave-Online, um, and you can too. I'm clearing out these files so I can upload the files that are relevant to this portion, and so if I download the file here, it only takes a second to download it, then I can delete it, and then I can take the next one, download it, delete it, and then I can take the next one and download it. Of course, these are some of them I'm going to be uploading right away, but just so you can see, sometimes it's nice to have a clear directory here, so you're not having to always look to see where your files are. So I'm going to pause now and load things up for the neural gas. Alright, so the 6 files that we're going to be using for neural gas are app1, app2, app3, neural gas network. This is the main command here. ngdata.bat will load in our data sets, and plot results will give us a chance to plot our results. So go ahead and load those into your Octave-Online. It just takes a minute to do it, and of course we'll get a bunch of error messages. Alright, so I'm just let's see, I'll go ahead and pick up, whoops, one of these. Where did that come from? Okay. I was just deleting some things while I'm looking. Okay, so app 1 is where we'll start. Let's take a look. So this is the file for app1.m, and initially we're just clearing out variables. Then we load the data, and so this is how the data is structured. This is kind of a pain that we're having to wrap around the words here. So we're loading in the data, and the data file that we're going to look at right now is called datafiles.ring. Okay, so I'm just pulling that in, and then I'm setting up the neural gas parameters. N is the number of clusters. Max iterations is the number, it's not the iterations, it's the number of times that you're going to go through the data. Okay, so Tmax should really be number of data points times maximum iteration, but that would take us too long. So 50 is okay. You can we'll try to bring this down a little bit. Okay, and then we have some parameter values down here. I've been playing around with these, so I'm just going to go ahead and get rid of all this stuff while I'm thinking about it, and this stuff. So sometimes, when you want to experiment, it's good to leave the parameters that you know are good, so that way you don't get caught. Okay, and then down here is the neural gas command. Oh, by the way, remember the epsilon initial, epsilon final? Those are the learning rate values, and lambda we said was like the neighborhood size, the neighborhood effect size for your data. Remember, that's that SIK divided by lambda. That's where the lambda comes in. And T initial and T final, these are the ages. We're going to start with an age of 5 and end with an age of 10. So if the age of the connection is greater than this number, then we'll remove it. Okay, and so this last command is really the only command that we really need. That's just the neural gas network. And so you feed in the dataset X, all the parameters in params, and then true or false. We're going to put it true here so we get the graphics feedback. But in Octave, it's probably better to leave that off or false. We'll see that in just a second. Okay, so that is the file that we're about to run. So I'll move over here, and of course, since I've been talking, I'll move this up too. Hang on one sec. Okay, so now we can just go ahead and run app1 and see what happens. Of course, be ready. Whoops. Oh, yes. This thing. So this uniform random number generator is what the author uses for this. And so um, you only need to write this once. So I just need to down here say package pkg load statistics, and then whoops, pkg load statistics. Okay, and now clear clc, clc, there we go. And now we can say app1, and we should get a graph. And you might have your cursor handy to hit the add 15 seconds button, because we'll need to do that a few times. And you can see how things are looking. They're looking good. That's looking really good. And so let's see if it'll add. Let's see if it'll let me finish the algorithm. I may have to decrease the maximum iterations. You can let me finish. We'll add 15 more seconds just in case. It's getting there. Yeah, you can see that it's in really good shape right now. But did we finish our number of iterations? I think I need to. I'll go ahead and let this hang up. Okay, so this is a partial plot because things didn't work out. Because if you type in whos, right, our network is not here. Oh, I should clear that data file out while I'm thinking about it. Oops. My keyboard is acting strange. Okay, hang on here. Something weird is going on. Okay. So let me come down here so I can show you what I'm doing. I was just going to say clear data file here. Oh, my keyboard is still acting up. I better save this. Let's see if I can change this. This is what I need to change in order to run without. Okay, my keyboard is acting really weird. I'm gonna have to. I don't know if that was Octave or because I just did something to it. But let's go back and try to run this again. Now that I've decreased the number of iterations a lot and removed the plot, I may have to hit the give me 15 seconds button again a few times. Let's see if we can actually get to the end of the algorithm. Yes, we made it. Why isn't anything showing up? Okay, type in whos. Good. And now if we want to plot, remember we plot results, and then it's the data file, and then it's net.w and net.c. There you go. So that's pretty good. We ended up like stopping early, but that's a good result. Okay, so this is how you will run your examples. And so the other two apps are really just different data sets. So app 2, you'll see brings in a horseshoe data set, and if you bring in app 3, it's a spiral shaped data set. Okay, so see if you can play around with these parameters and get the spiral and the horseshoe to work out good for you. Okay, so it's just like we did. So we did the first data set together. You just have to do the other two. So that's just changing app2.m and app3.m. Good. Okay, I'll see you later.